Alright, in this video we're going to continue with looking at quadratics and attempting to factor them. But we're going to run into a problem on this particular problem that we have here on this quadratic because it doesn't have any real solutions. And when I say real solutions, it does have solutions, but we call them complex solutions. And they're going to be, when I write my answer, I'm going to have it in the form of an imaginary number. So you'll see what I mean by that. Hopefully you looked at the tutorial on imaginary numbers already, and you looked at the tutorial for factoring quadratics. And now you can see we're kind of going to the next level here in this Algebra 2 type problem. But before I dive into it and I start actually attempting to factor it, because this one's going to show that it's not factorable. And when we run into that issue, we're going to have to resort to the quadratic formula to get our answers. And I want to show you why, visually, it's not factorable. And so I'm going to come over here real quick, and I'm going to go to y equals, right? We're going to graph it. And previously I had made a video with one, and here it is right here. And you could see that it has two solutions, right? Two real solutions. It crosses at -7 and at +5. Now on this problem, I'm going to type it in, and you're going to see that we have what looks to be no solution because it doesn't cross the x-axis. But it does have a solution. We just call it a complex solution. And so I'm going to go ahead and put in x squared and minus 4x, and then we have +5. So they already have it set equal to 0, which is what we want. So we just put in what's on the left side of the equal sign, our three terms, and I'm going to hit graph. Notice that when this comes down, right, you're going to see it never crosses the x-axis. Therefore, there are no real solutions. However, there are complex solutions that are going to contain what we call imaginary numbers. So let's take a look at how we solve it and how we know that this is the case even without graphing it. Because you don't have to graph it to realize that's the case. One of the things that you'll notice right off the bat is that you can't factor it. So I'm going to draw my number tree like normal, right, where we would normally factor it. And notice we have three different terms. We have our a term, right, because this is ax squared plus b. So we have our b term, right, plus c. That's my c term. Now we want two numbers that would multiply to give us 5 and then would combine to give us -4. So this one would be easy, right, because this is a prime number here. So our factors are just going to be, for 5, are just going to be 1 and 5. And so some of you might look at it and be like, oh, well, you know what, Mr. H, we can get a 4 out of a 1 and a 5. And it's true. But we're going to run into an issue here. So now, right, it's got to multiply to give me +5. So that would mean that it's either got to be negative, or it's got to be positive. Now if we left them positive, we would have 1 plus 5, which would give us 6. And this is not a 6, right? Our b is a -4. And if we said, well, let's make them negative, okay, so we had a -1 and a +5, we could get a 4 that way. But if I multiply -1 and +5, then that's going to give me a -5, because a negative times a positive is a negative. But this is a +5. So what you run into here is no matter what you do with the signs on it, we can never get the two terms to multiply to give us +5 and to combine together to get us -4. So in Algebra 1, you would have just said this is not factorable. Almost put non, but we'll put not factorable. Now it doesn't mean that it can't be solved. It can be solved. We just can't do it with factoring. Now, so when you run into one like this, where you cannot find any combination of its factors to be able to give you those two terms, right? Like this case, +5 and -4. Then what you want to do is you want to go ahead and go to the quadratic formula, and we can use it to solve it and get our complex solution. I'm going to show you what that looks like. Now notice there's some letters here. You see a B, A, and a C. And this shouldn't look completely new to you because you did use the quadratic formula in Algebra 1, even though it was for a very limited amount of time. And our letters, our variables, notice this is our A value is 1, our B value is -4, and our C value is +5. So what I'm going to do is I'm going to go ahead, I'm going to substitute these values. So let me rewrite this real quick. But I'm going to put parentheses in place of the letters that we're going to replace. And all the letters we're going to replace are in orange. So for instance, we're going to put our B value there, and then it's going to be plus or minus the square root of, and we have our b value again in here, so I'm going to put a set of parentheses, but it's going to be squared, and then -4 times parentheses, because that's going to be my a value, and parentheses, that's going to be my c value. And then in the denominator, we're going to have 2 times our a value. So now we're just going to start substituting numbers. So for my first one, right, for b, I'm going to go ahead and take the b value of -4, and I'm going to take its sign with it. I'm going to put it inside of the parentheses. And then we have b again right here, right? So there's another b right here, b squared. So I'm going to put -4 squared. And then we have -4 times a. So for my a value happens to be 1. So I'm going to put a 1 right there in place of the a. And then it says times c. And our c value is +5. So we're going to put a +5 in there. And then down in the denominator it says 2a. So in place of that a, we're going to put the a value, which is 1, once again. So all I did was substitute the b value in 2 places, the a value in 2 places, right? The denominator and the numerator, both of them had an a, and then our c value. Now in Algebra 1, whenever you did these, most likely your teacher would have you, if you didn't do it by hand, because I had my students do it by hand and with the calculator, you would just throw it in the calculator and you would get an answer. But I can tell you, if you were to throw this into the calculator, you're going to get an error. And that's because there's going to be a negative value inside of the radical. And when you have a negative value inside of a radical, it's going to give you an error. And I just want to show you, in case you were doing this and you were trying to rush through it on a test. Now I would always tell my students, it says plus or minus. You can't do plus and minus at the same time. So usually I would do the first equation with plus and then copy it and add the subtraction sign in it in place of the addition sign, and you could do your second. But let me show you what I mean. I'm going to hit alpha y equals and enter to get my fraction bar, and I'm going to go and start putting in these symbols. So I have negative, parenthesis, -4, close parenthesis, hit second, x squared, and we're going to put in what's on the right side now. So we have -4, so parenthesis, -4, close parenthesis, squared, -4 times 1 times 5 over 2 times 1. Alright, I'm going to hit enter real quick. Oh, I thought I hit 1. It didn't take it. There it goes. I'm going to hit enter. And notice it says error, non-real answer. That's because we don't have a real solution, right? We have a complex solution. We have an imaginary number in here, and this calculator won't do it for you. So unlike Algebra 1, where you could get away with doing these in a calculator and by just substitution and throwing it in a calculator, you actually are going to have to do this by hand. And so let's go ahead and let's work this out by hand. It may look complicated, but it's really not. And we're going to do this step by step. Now, first thing I want to do is I want to distribute this negative that's right here, right? Anytime there's a negative outside the parenthesis, it's really just a -1. And that's like saying -1 times -4. So I'm just going to write down kind of so you can see all the steps I'm doing. -1 times -4. That's what's happening right here. And that's going to end up giving me, put me an arrow here, a +4. Now if you done kind of forgot the rules about negatives being multiplied to negatives and whatnot, you could always go back to your calculator and just do it by hand. Say -1 times -4. And you'd see that it's +4. And then I'm going to write plus or minus the square root of, and notice I'm just going to focus on the numerator first. In other words, I'm just going to focus what's on top first so I don't get overwhelmed with too many numbers. And then I'll focus on multiplying the 2 times the 1 and dividing that out. Alright, so this next one we have parentheses, right? And it says the -4, and then it says squared. And then we have this -4 times 1 times 5. Now for me, I'm actually going to put all these values in the calculator. I'm just not going to put them in the radical. Because if you put it in the radical, it's going to give you an error. So let me highlight what I mean. So all this that you see me highlighting is going to go into the calculator, but not the radical symbol. So let's take this real quick. I'm going to go in and put my parenthesis, -4, close parenthesis. I'm going to square it, and then -4 times 1, and then times 5. Alright, we're going to go ahead and we're going to hit enter, and notice it gives me -4. So this actually becomes -4. And this is why that calculator was giving us an error, because we cannot have a negative value as our radicand inside of the radical. Now I'm going to go ahead and draw my division symbol over, and then 2 times 1, well that's easy, right? 2 times 1 is just going to be 2. So now this answer looks much more simple, right? We have 4 plus or minus the square root of -4 over 2. This creates a dilemma for us. because we know that we cannot get the square root of this with that negative value in there. So we're going to have to break it up, and we're going to have to simplify it. And this is where the imaginary number part comes into play. So let's go ahead and let's work this out. I'm going to work it out two ways, because we have plus or minus. I'm going to do them separate, and then we'll kind of put it together so you can treat it as two separate problems. And so when I rewrite this, I'm going to write this as 4 plus the square root of negative 4 over 2. That's going to be one solution. And the other solution is 4 minus, right, because it's plus or minus, the square root of negative 4 over 2. And then we can further break this down. So I'm going to move it up because I'm going to really go into detail and show exactly all the steps that we're taking to break this down. Now, if I wanted to break this down further, I got to get rid of that negative sign. So what I'm going to do is I'm going to split this radical up, like in the lesson that I taught you on imaginary numbers. We're going to split it up and take out that negative 1. In other words, it's going to be expanded as 4 plus the square root of negative 1 times the square root of 4. So now I've taken the negative 1 out of that square root of 4 and put it over here by itself. And this will all be divided by 2. Now if I wanted to simplify it further, I could. I'm going to go ahead and I have 4 plus. Now remember that this square root of negative 1 just becomes I. So that would become an I. And then we have times the square root of 4. Now, we know what the square root of 4 is, or at least that's one that I actually remember, and hopefully you do as well. But if you don't, it's okay. I can come over here and I can go ahead and hit second, x squared to get my radical symbol. I can put a 4 in there, hit enter, and the square root of 4 is just simply 2. So really, and you're going to see me just continue to rewrite this, because I'm showing you each time that we make it a little bit more simplified, how it looks. So I could rewrite this as simply 4 plus, and then that square root of 4 turns into a 2. So I'm just going to put an arrow there, 2, and then the I, I'm just going to put it after the number, because we always put the I at the end. So put the I after the 2. So square root of 4 turns into positive 2. And the I just bring it down. So the I, I'm just bringing it down and putting it at the end. And then this is over 2. And we're almost done. Now the thing is, we have this, right, we're dividing this whole thing by 2. And what I like to think of is, when I think of it dividing by 2, because this may look confusing to you, that there's 1, 2, and you may be tempted to just divide the 4 by the 2 and not divide it into the 2. At least I'm tempted to do that all the time. So I like to break it up into 2 different fractions. I like to say one of these is 4 divided by 2 plus 2i divided by 2. And this helps me not forget to divide into both of those terms. Now 2 will go into 4 2 times. So that becomes 2. And 2 will go into 2 1 time, right? So we like to say they cancel. So this just becomes plus 1i. Now remember that there's always an invisible 1 in front of every variable. So in this case, you really don't have to write the 1 in front. You can just leave it like that. And this is one of our solutions, would be 2 plus I. Now we would follow the same process on this one over here. It's the same process. The only difference is instead of saying plus the I, we're just going to have minus the I. So we could work that all out. And this one I'm going to do it a little bit faster. So let me put an arrow here. In other words, this is going to be 4 minus the square root of negative 1 times the square root of 4 divided by 2. And if we go ahead and convert this square root of negative 1 to an I, that becomes an I. And if we convert this square root of 4 to a 2 and we rewrite it, we just end up with 4 minus 2i divided by 2. And then if we were to divide the 2 into 4, it'll go in there 2 times. Divide the 2 into 2, it'll go into there 1 time. And we end up with just 2 minus I as our other solution. Now a lot of times what you're going to see is in your final answer on the test, it'll have these written where like this, it'll combine it and it'll say 2 plus or minus I. And whether you put this single statement, 2 plus or minus I, or you decide to go ahead and not have a single statement, but write it out as two different complex solutions, it's both correct. In other words, you could say these two separately, 2 plus I and 2 minus I, or you could just say your answer is 2 plus or minus I. Now, this is unlike anything you did in Algebra 1, because in Algebra 1 you never dealt with complex solutions. You never had an answer that I in it, but now you do. So I'm going to do one more of these just to go ahead and make sure that you have this down, right? And I may not show the steps so detailed, but in this case, this first one, I really wanted to make sure that I slowed down and showed every single thing that I was doing in order to get your final answer. And this is called a complex solution because it's made up of an imaginary number. And let me be sure not to not forget to put this as x equals 2 plus or minus I.